Hello friends, welcome to our YouTube channel. In today's class, we are going to discuss about the Malus law. Okay, the scientist Malus he gave an important law regarding the polarization of light. So according to him, when a completely plane polarized light, when it is incident on an analyzer, then in intensity of the emerging ray, it is directly proportional to square of the cosine of the angle between the polarizer and the analyzer. Okay, so we have seen that polarizer and analyzer, if we kept there, we will see in the diagram also. Then if we change the angle of the analyzer, we will get the different output. So that intensity of the output, it is directly proportional to the square of the cos theta. Okay, the angle between polarizer and analyzed. Okay, so according to this, what is the equation for this? I, intensity of emergent ray, it is equals to I naught, it is a proportionality constant, cos square theta. Okay, I naught cos square theta. Now observe this diagram. Malus first time discovered that whenever a ray of light it is incident on a transparent surface, at a particular angle we are getting the reflected ray as a plane polarized light or the polarized light. Okay, so this concept we put forward that plane polarized light, when it is coming from the polarizer and then incident on the analyzer, then what would be the output? Here with the diagram I have shown that polarizer, analyzer. Okay, so see at the left hand side, the unpolarized light is falling on the polarizer. Okay, unpolarized light means it can move in all directions. So by wave diagram also it is shown, the waves can come in along any direction. Okay, so when it come across the polarizer, it polarizes it and only one direction light is allowed to pass through the polarizer. It is plane polarized light. Okay, the straight line, it is plane of polarizer. Now another polarizer as an analyzer, it is kept in front of the polarizer with the same axis. Okay, so here the axis of analyzer is also shown as a parallel to the axis of polarizer. If we change the angle of that analyzer by angle theta, see here the analyzer, it is just slightly tilted its axis by some angle theta, that is given by a different color here. Okay, so that angle theta is the angle between the axis of polarizer and the axis of analyzer. So what we are getting, the output intensity emergent ray, that means output from the analyzer. Analyzer now can pass only the lights that can pass through that tilted axis. Okay, so the intensity of that output, it is directly proportional to the square of that cos theta, means angle, cosine of that angle. So here it is by the diagram. Okay, now we will prove this Malus law with the mathematical expression. Now here see the vector diagram I have shown for the polarizer and analyzer, mostly for the analyzer, कारण analyzer मधूनच आपल्याला जे ते आउटपुट मिळतं, ज्याच्या इंटेन्सिटी बद्दल आपण बोलतो. Okay, so here E represents the axis which is exactly parallel to the axis of the polarizer, and this different color, that is the axis of the analyzer after the tilting. So the angle between these two axes, it is theta, as we discussed in the earlier diagram. Okay, now E, if we see that E, another there is E2 also, one direction, E1 is one there. According to electromagnetic theory of light, the E will represent the electric component of the light ray which is coming from the polarizer. Okay, now this electric component, it will now divide into two components, E1 and E2, along these two direction. Okay, so according to vector resolution, we are getting these two direction. One direction, it is exactly same as the axis of the analyzer, that we have already discussed, that it is E1. Okay, making some angle theta with the axis of polarizer. And E2, it is the backward direction component and it is blocked. That means no ray can pass through this way. Okay, so we are having here only the one direction, that is the E1. So E1 represents the transmitted electromagnetic wave. Okay, now to solve this we will make some arrangement, that construct this as shown here. Now here we are getting we can use the vector sum. Okay, parallelogram vector sum, or simply the vector sum method we can use here. So according to this, what is the value of E? E will be the addition of E1 plus E2. Vector E1 plus vector E2 will give us E. But here E2, it is in the backward direction where there is no output. So it is not there. So E is equals to E1 in the vector format. Okay, so how to solve this? Now observe the triangle where theta is there. In that triangle we can use the trigonometry. Okay, find cos theta. Cos theta is equals to, here it is E1 upon E. Okay, so find that cos theta. Cos theta is equals to E1 upon E. Then E1 is equals to E cos theta. Okay, E1 is equals to E cos theta by cross multiplication. Now squaring both the sides. If we square both the sides, we are getting here E1 square is equals to E square cos square theta. And we know that this is this square of this quantity, that means it is represents the amplitude. This E quantity represents the amplitude for the wave, electromagnetic wave. So E square means, we know that intensity is directly proportional to amplitude, square of the amplitude. So here we can say that E1 square means from the analyzer intensity that we are going to find. So it is I. So E1 square is nothing but the I. And E square, it is the original intensity of the incident ray from the polarizer. So it is nothing but the I naught. So I is equals to I naught cos square theta. So here we get that intensity, output intensity I, it depends on the square of the cosine of the angle theta between the analyzer axis and the polarizer axis. Okay, so this is the proof for the Malus law, what he state, that is proved in this mathematical expression. Okay, so hope you understand this expression. If you have any doubt, please comment here, like our videos.